Hi, so in the last video we looked at differentiating the arcsine function. So what we're going to do now then is differentiate the arccos function. So again, by arccos we just mean the inverse cos function. And again, it's going to be a very similar video to when we differentiated arcsine of x. We're going to just use some implicit differentiation to help us out with this, since we already know how to use the chain rule from previous videos. So yeah, what we can do then, a similar technique to when we differentiated the natural log and to when we differentiated arcsine, we'll just say that we'll just let y equal arccos. So let y equal arccos. And then what we can do to both sides is just apply the cos function to both sides. So again, the inverse of the arccos function is just the cos function. So if we apply the cos function to both sides, then that's going to get rid of the arccos on the right side. So we're going to get cos of y equals x. And then the technique again that we did in the previous video is we just differentiate with respect to x on both sides. So apply d by dx to both sides. And then when we do that, so on the first side, we're going to get d by dx of cos y. And on the second side, we're going to get dx by dx. Well, that's just the number one. So we know then that we've got d by dx of cos of y equals the number one. So then we're going to have to use a bit of chain rule or implicit differentiation to do this left-hand side. So again, we've got cos, which is a function, and this y, which is a function of x. So namely, arccos of x. So we can do basically the chain rule because we've got a function of a function. And so to differentiate this function of a function, so cos of y of x. So using the chain rule formula that we did in previous videos, so we differentiate the y of x with respect to x, and then we multiply that by the derivative of the cos of the y function, but with respect to that function in there. So with respect to the y function. So that's just applying the chain rule formula. And using that chain rule formula, we can simplify this and get dy by dx, because we can't really simplify this first bit, this first term in the multiplication. And then when we differentiate cos of y with respect to y, well, that's just minus sine of x, because again, we know that from a previous video too. So then simplifying this, we get negative sine of x multiplied by dy by dx. And so we can just substitute this in to the left-hand side up here. So we get negative sine of x dy by dx equals the number one. And then we can divide both sides by negative sine of x to get dy by dx on its own on the left side, because that's what we want to calculate. We want to calculate dy by dx because y is arcsine of x. So we're going to get negative 1 over sine of x. And of course, it doesn't matter whether we put the negative sign on the top of the fraction or the bottom, because dividing by -1 is exactly the same as multiplying by -1. Okay, great. So we know that dy by dx, i.e. the derivative of cos of x with respect to x, is -1 over, sorry, my bad, this should be a y. Sorry for that. Because yeah, we're differentiating y, so this should be a y as well. Sorry, I'm making the mistake there. So that's y, and that's y in there. And also that's y down there. Okay, great. Yeah, so everything's fine now. So we know that the derivative with respect to x of arc cos of x is -1 over sine of y. But we've got this y variable there, which we don't want because we're dealing only with the x variable. So we're going to have to use some trig identities like before. So like in the arcsine derivative video, we use this sine squared plus cos squared equals 1. If we make sine the subject to the formula, we would just get sine equals the square root of 1 minus cos squared of x. So this time I'm going to make sure that I'm using the right variables in this equation up here. So we're using y's instead of x's on the right hand side. So we've got -1 over the square root of 1 minus cos squared of y. And okay, so if we go back to the previous page, or the previous page before that, so we know that cos of y equals x. So cos squared of y, or cos y all squared, is the same as x squared. So we know that this here is actually just the same as 1 over the square root, sorry, -1 over the square root of 1 minus x squared. And so in conclusion, when we differentiate with respect to x, arc cos of x, we get -1 over the square root of 1 minus x squared. And that is the final result.